Here we work on the square root method, which is a method used to solve like easy quadratics that are already in what's called vertex mode. So I want you to notice something that is similar between all four of these examples. X squared minus 49. Notice there's only one term that has an x in it. Here's x plus 10 squared equals 9. You have this quantity that's squared. You don't have like an x squared and a 10x, for example. You only have one x. Same thing here. Since the square is on the outside of the parentheses, you should be able to isolate the y. Here also, there's only one variable y. We should be able to isolate it. This is different from the previous examples where I had two terms, one involving an x squared, one involving an x. This one as well. I have an x squared and a minus x. Two terms, one involving an x squared, the other an x. So when you don't see two terms involving an x, then likely your equation is already in vertex mode. So it might look something like this. A times x minus h squared plus k equals 0. So there's only, and we'll come back to this like vertex mode equation in the next chapter. But notice that there's only going to be one term that has an x in it. All right, so the method, the square root method, is really similar to solving linear equations in that our goal is to kind of get x by itself isolated. So here, I'll move the 49 to the other side by adding 49 to both sides. So I get x squared equals 49. And once you have the square isolated, you can go ahead and take the square root of both sides. But then this is going to generate two separate equations. You get x equals the square root of 49, which is 7. Or x equals negative square root of 49, which is negative 7. So this, taking the square root of both sides, this really generates two equations, and sometimes we write it with a plus minus sign, like x equals plus or minus 7. Just note that that really is just shorthand for saying two separate equations, x equals positive 7 or x equals negative 7. Let's do this next example. First, I'll isolate the squared term, trying to get x by itself. So it's already isolated. I got 9 on the other side. Then the method is to square root both sides. And when we do that, notice we're going to get two equations, a plus equation and a minus equation. Okay, the square root of x plus 10 squared, square root and the square undo each other, and we're just left with x plus 10 equals plus or minus the square root of 9, which is 3. All right? And now, once we have this statement, I can go ahead and split that up into two separate equations. X plus 10 equals 3, or x plus 10 equals negative 3. Okay? Subtract 10 from both sides. We get x equals negative 7. Subtract 10 from both sides. We get x equals negative 13. So again, think about what our method was. First thing, isolate the square. Second procedure is to square root both sides. This introduces a plus or minus symbol. Once you've done that, you can split it to two equations. And solve. It's really like a three-step process. Let's go ahead and do the next problem. 3 times y plus 8 squared equals 54. So notice it's already almost there because the 54 is on the other side, but there's this pesky 3 in front. So I'm going to get rid of that so I can kind of get the square by itself. I'll get rid of that by dividing both sides by 3. 3 divided by 3, that's 1, so those cancel. So we get y plus 8 squared equals 54 divided by 3, which is 18. All right, now that I got the square by itself, I'll go ahead and take the square root of both sides, which gives me 2 answers, right? Y plus 8 equals plus or minus the square root of 18, which I think that can be simplified, because 18 is 9 times 2, and 9 is a perfect square, right? 3 times 3. So a group of 3's can come out, and there's a 2 left underneath. Okay, we're almost there. Now I'm going to split this into 2 equations. I'll have y plus 8 equals a positive 3 root 2, or y plus 8 equals a negative 3 root 2. Subtract 8 from both sides, you get y equals negative 8 plus 3 root 2, or y equals, subtract 8 from both sides, negative 8 minus 3 root 2. Now I want to just draw your attention to something here. This should look familiar in that negative 8 plus 3 root 2, negative 8 minus 3 root 2. Notice that when you get like a strange answer, like a like 2 complex numbers or 2 radical numbers, notice that they're going to come in conjugate pairs. They're conjugates of one another. And that's always going to happen. Whenever you get one of these strange solutions that has a radical or an I in it, you're going to get 2 of them that are conjugates of each other. All right, last example. 4y minus 24 squared plus 32 equals 0. Let's go ahead and subtract 32 from both sides. So we get 4y minus 24 squared equals a negative 32. We'll go ahead and take the square root of both sides. So I get 4y minus 24 equals plus or minus. Now, the square root of negative 32. I want you to notice that negative symbol inside the square root. That's going to pop out front as an I. That's going to be an imaginary number. So it'll be I root 32. Okay, and root 32 here. Hopefully you can notice that that's 16 times 2, and 16 is a perfect square that can come out. So let me just rewrite this one more time. The square root of 16 is 4, so 4 comes out, so I'll have 4i on the outside, and there's a 2 left on the inside, 4i root 2. Great! I am almost done. Now what I can do is separate this as 2 equations, and then solve for y. So we got 4y minus 24 equals 4i root 2, or 4y minus 24 equals negative 4i root 2. Let's go ahead and solve this one first. I'll add 24 to both sides. 4y equals 24 plus 4i root 2. And dividing both sides by 4, we get y equals 24 over 4 is 6 plus I root 2. And then I'm going to make a prediction that the other solution is going to be 6 minus I root 2 because I think they're going to be conjugates. But let's just check. Add 24 to both sides. 4y equals 24 minus 4i root 2. And then divide both sides by 4. We get y equals 24 over 4, which is 6. 4 over 4 is minus I root 2 is left. And I was right. We get 2 solutions to the equation, and they're conjugates of each other. So again, method for solving quadratics using the square root method. You really only want to use the square root method if it's like already in that vertex form, where you have either just one variable squared or a quantity with a variable in it squared and no other instances of the variable. If you do that, get the square by itself, take the square root of both sides, which introduces the plus minus symbol, split it into two separate equations, and go ahead and solve those, and that will give you your potentially two solutions.